Welcome to part 2 of NumPy. So what we're going to be doing, the first thing we're going to do is we're going to look at NumPy indexing and selection. So what I have is I have a command shell opened up and I've imported my NumPy library. So the first thing I'm going to do is I'm just going to go ahead and create an array, and it'll be numbers 0 through 10. So if I go ahead and display that, we have the numbers 0 through 10. You can use slicing to get values at a single index like you can do on lists or strings with Python. So if we want to get the value at index number 8, we can just use the square bracket notation, and what that'll return, it'll return the number number 8 for us. Okay, so the next thing we're going to do, you can in your slice notation, you can specify the start and the end. So what we're going to do here is we're going to start at index 1. And we want to return values up through but not including index 5. So what we're going to return is 1, 2, 3, and 4. You can go ahead and specify this next one. We're just going to get starting at position 0 through position 5. So that'll include 0 when we do this slice. You can get everything starting at a specific or running up through a specific index. So we could have written the slice above as follows through index 5, and that would have returned the same value. If you don't specify a beginning index, it'll start at 0. And then you can start at a specific and run all the way through the end. So if I type in 5, so we want to start at the index position 5, and we want to run through the end of our array so that it will include everything from 5 through 10. So the difference between Python lists and NumPy arrays is their ability to broadcast. So what we can do is we can go ahead and take a specific slice from an array, and we can go ahead and set all those values to a specific value. So if I go ahead and enter 100 here and then check out my array, now basically what I have from position 0, 0, 1, 2, 3, 4 through position index 4, but not including 5. All of those values have been set to a 100, whereas the rest of the values stay the same. So that's one thing that's different between a list and an array in NumPy, is that you can go ahead and broadcast. So what we're going to do next is we're going to look at how you can index a two-dimensional array or a matrix. So the first thing I'm going to do is I'm going to go ahead and create a two-dimensional array, and we will just call it R2D. And what that is going to equal to is, let me just go ahead and type in the command to create it. So basically we have row 1, row 2, and row 3. So it should be a 3 by 3 two-dimensional array. And it is. Row 1 is 5, 10, 15, or row 0, 5, 10, 15, row 1, 20, 25, 30, and row 2, 35, 40, and 45. So there's two different ways that you can go ahead and index individual elements in a two-dimensional array. The first one is double bracket notation, and the second is single bracket notation. So I'm just going to provide you an example of double bracket notation. So if we wanted to retrieve 5 in our array, basically that's at position in row 0, column 0. So what we can do is we can, in multiple square brackets, we can just specify the index. We want to access the value at index 0, 0, and that will return 5. If we wanted to index a whole row, we could just go ahead and type the following. And if we go ahead and enter, that'll retrieve the whole first row for us. The next thing we're going to look at is, say for instance, if we want to get position or number 25, basically it's in row 1 and column 0, column 1. So it should be 1, 1. So if we go ahead and specify that, we will return 25. And then finally, if we wanted to get 40, again, that is actually in row 3 column, or row 2 column 1. So we have 0, 1, 2, and then column 1. So it would be the value of 2 and then 1 in square brackets. And that would return 40. Well, this is kind of a little error prone, so the thing that you can do is you can just go ahead and use single bracket notation. So when you use single bracket notation, you just put both your row and column number within a single bracket and separate them by a comma. So if we wanted to get 0, 0, we could just separate them by a comma. That'll return 5. If we wanted to get 2, 1, we would just 2, comma 1. That'll again return in row 2, column 1. So simple single bracket notation is a lot less error prone, but you may see where double bracket notation has been used in the past. To get chunks of an array, you can use the slice notation. So what we want to do is we want to go into this array and we want to gather 10, 15, 25, and 30. So it looks like we want to start at row 0 up through, but not including row 2. And then our columns, we want to start at column 1, and we want to include columns 1 and 2. So what we can do to go ahead and do that slice, first what I'm going to do is I'm just going to type in the slice needed to get the row information for us. So again, we want to start at column 0 and go through column 1 and not include column 2. So that should return our first 2 rows. And then what we want to do for our columns is we want to go ahead and return starting at column 1 up through the end. So I can just go ahead and specify that, so that'll return the 10 and 15. So now if I go ahead and just combine those two, we'll just go ahead and specify. So we want :2, comma, and then we want 1 colon. And what that should now do is return out of our original two-dimensional array 10, 15, and 25, 30. So that's how you can go ahead and grab chunks of an array using slice notation. The next thing we're going to look at is something called conditional selection. So I'm just going to go ahead and create another array. And we're going to start at, it'll be the numbers 1 through 10. So if we want to go ahead and display all of the numbers that are greater than 5, we can go ahead and use something called conditional selection. So what I'm going to do is I'm just going to go ahead and create a Boolean array. And on my right hand side, all you have to do is specify the name of your array and what you want to check each value against. So what we're telling this is we want to return a Boolean array. Within that array, it'll tell us either using false or true if that value in the array at that index is greater than 5 or less than and equal to 5. So if I hit enter, and then I go ahead and display my Boolean array, we have falses for 1, 2, 3, 4, 5, and then trues for the rest of the elements. So we can use it to actually get the values. So all I have to do is type in R and then pass in my Boolean array. And what that'll do is that'll display the numbers 6 through 10. The other thing you could do is you can combine it into just one step. So what I'm going to do is I'm going to specify the name of my array, and then within the square brackets I'm just going to go ahead and specify my condition. So I want greater than 5, and what that'll return is the array. If I wanted an array with just the elements less than or equal to 3, I could just go ahead and specify that. And again, what will get returned is those elements that are less than or equal to 3. And the final thing we're going to look at is some NumPy operations. So the first operations we're going to look at are array with array operations. So what I'm going to do here is I'm going to go ahead and create another array, numbers 0 through 10. And the first thing I want to do is you can add two arrays together. So what this actually does is it takes the elements, and for each one of the items in the array, and it just adds them together. So in this case it just doubles them. So we'll go back to our original array. You can do minus. So if I hit array minus, basically it subtracts the two arrays from each other and I get all zeros. My original array is still in place though, and if I multiply them, basically what that does is we're taking the square root, or we're squaring each one of the elements in the array. So there are array with scalar operations. So if we want to go ahead and take our array and add 100 to each one of our array elements, we could just specify ARR plus 100, and then each one of our elements, 100 has been added to them. Let me go ahead and get my initial array back. If I want to subtract 50 from each element, basically what that does is it subtracts 50 from each one of the elements in the array. So those are using scalar operations with an array. If I wanted to get the use exponentation, I could just go ahead, type in. So if I want to square each one of the items, I can just go ahead and use exponentiation. And then the final functions are, there are tons of universal array functions. So if I go ahead and specify sqrt, basically what that's going to do, and specify the name of my array, it will take the square root of each of the elements in my array. So let me just go ahead and type that in. That'll take the square root of each one of those, and then the next one you can get exponentiation, exponent. So I exp, type in ARR, and that'll go ahead and get the exponent. So there are various different types of universal array functions. So let me go into, there's a website, it's docs.scipy.org _doc. backslash doc backslash numpy reference ufuncs.html. If we go ahead and scroll up to the top, it has a list of all the universal functions. So if you scroll on down, there's tons of different math functions that you can go ahead and use. Trigonometric functions, sine, cosine, tang, arcsine, arccosine, tons of those. Bit twiddling functions, comparison functions. So there's tons of different functions that you can use within NumPy arrays. So that's all I wanted to cover in this video. So in part 3, what we're going to do is we're just going to go through a few exercises using some of the tools that we just learned. So I will be back to you in a few minutes with part 3.